All right, we're going to continue our topic on dimensional analysis just by looking at metric conversions, right? It's not going to be good enough just to like move the bubble anymore. We want to use this idea of dimensional analysis to help us with this idea of conversion. So it's really actually easier than what we started with. It's just understanding our prefixes and what they actually mean, right? And so that's what we have right here, right? The rule is based on prefixes. It's still about finding the ratio. The problem is the ratio is not something I'm going to give to you in a problem. The ratio is expected something that you're able to discover on your own, knowing the MKHD, right? Base unit, DCM, U, and P, right? If you have that in mind and you understand where those lines are, you're going to be good. All right. So the idea is for this one, we need to find the right ratio. Basically, we find the biggest unit and it gets the number 1. We find the second unit and we figure out how many jumps away it is, and that's a multiple of 10. And from there, we arrange it to use our dimensional analysis. So the dimensional analysis part is actually pretty easy. We can do this in 1 or 2 steps. Sometimes I show it in 2. Lots of times it's just as easy to do it in 1. And we'll try that on a problem like this. So we have this box, right? And in order to solve this problem, we have to have numbers that look like that. So if I want to solve the volume of the box, I would just multiply all those numbers together, right? Length, height, and width, and I'd be good, except for when that comes up, right? That makes a huge difference. And if I just multiplied those numbers by what we're seeing right there, would I end up with the correct answer? And the answer is no. I can't multiply meters times centimeters times millimeters and come up with the right answer, right? So what we need to do is we need to do a conversion. Now, most of these are pretty easy, right? You could probably do some of these in your heads, but we're going to use these easy ones in order to show what it is we're going to look at on the next set of problems. So let's take a look at this. So again, we have our box and we have 3 numbers. We have 0.025 meters, and we have 5.5 centimeters, and we have 32 millimeters, right? That's our sets of data. Now, all we need to do is we just need to pick one. We need to convert to the other ones, okay? The other thing we want to know when we're doing this is just like what I said before. So let's write this down. We have M, K, H, D, base unit, deci, centi, milli, micro, nano, pico. Put lines right there to help you out, right? Be good at that. Be good at that. Okay, so knowing that, it doesn't matter which one we pick, but because meters is the base unit, right? I know that a meter is right here, okay? A meter's not right there, right? A meter's not over there. A meter is a base unit, and it's right there. So what I want to do is I want to use our idea of dimensional analysis to get the job done. So again, dimensional analysis is pretty easy. Centimeters, go on the bottom. What am I trying to convert it to? I'm trying to convert it to meters. On our last slide, we saw, oh, when you do this, you give the bigger unit a 1. Well, this is the big side. This is the small side. So you just pick out the side that is closest to the big M. Well, that's this guy. He's right here, right? Meters is right there. So I'm going to give this a 1, and I'm going to figure out how many jumps away it is. It's 1, 2, right? And so it's simply just doing 10 to the second. Remember, all of those are a jump of 10. So if we do 10 to the second, we're done. Gone. And yes, I know you can do this in your head and you can move the bubble. But if I ask you to show work, this is what I expect. And so when we do that, we have 5.5 divided by 10 to the second. And I end up with, geez, no kidding. Good thing I looked at that. Divided by 10 to the second. All right. So I have 0.055. So 0.055. And my new unit is meters. Okay. Doing the same thing down here in millimeters, right? Milli is going to go on the bottom. Meters is going to go on top. It still doesn't change. That one's still the big one because milli's right there. Okay. This one is 1, 2, 3 jumps over. So this is going to be a 10 to the third. And so what I end up with is 0.032 meters. Now we can do our math, right? Now we can do it. Now we can take that times that. And so I end up with 0.025 times 0.055 times 0.032. And my calculator tells me I have 4e minus 5. So that equals 4.4 times 10 to the negative fifth. Is that the right number of sig figs? Yes, it is. All of our numbers that we started off with had two significant figures, so that's good to go. That's a good answer. Okay. All right. Let's take a look at the next one. Okay. Doing some of these. I'm going to do the first two just to kind of lead you back through it, and then I'm going to have you finish with the last one in our ed puzzle. Okay. So 2 more examples, and then it's on you. So I'm going to start with what I know. I know that for this A, I have, geez, you can't see it. Okay, so write those down, press pause, write them down, and then let's go back over here. All right, so for this A, okay, I have 1.3 times 10 to the third decagrams. Okay, and what I want to do is I want to convert that to kilograms. All right, that's good. So what is I'm going to put decagrams on the bottom because I'm trying to get rid of it, right? And I'm going to put kilograms on top because that's what I'm trying to go for. So if I do this, I end up with kilograms as my unit. Perfect. Okay. Now I take a look at those. Which one of those is bigger? Well, let's take a look up here. Kilos right here. Deca's right there. So kilos bigger. It gets the 1. It's not always on top. That just happens to be how these problems worked out for these first couple. Okay. And what I'm going to get to is I'm going to do deca is on the bottom, and so that's a jump of 2 away. And so if I do that, I get a 10 to the second. Okay? Doing the math, the nice part about doing it this way is we know when we divide by exponents, all that happens is they subtract. So I get a 10 or a 3 minus a 2. That gets me a 1. And so I know I should have about 13 or 1.3 times 10 to the third, but we could put in our calculator just to check, right? So let's do that. So I get 1.3 times 10 to the third, right? And I'm going to divide that by 10 to the second. And my answer is 13, right? That's where the mental math can help you actually answer these a little bit quicker. 2 sig figs. We have 2 sig figs out there. Perfect. Good to go. All right. Doing this next one, so let's do this B, and this will be our last one, is we have 6.78 times 10 to the negative fourth megaseconds, right? Big M, be careful with that. And we want to convert that to centiseconds. So megaseconds is going to go on the bottom, centiseconds is going to go on top. Megas get canceled. We're left with centa, which is what we want. That's the question. So we take a look at those. Between a mega and a centi, which one's bigger? Well, mega's right here, centi's right there. All right. Mega gets the 1. How many centis is it? Well, let's go. It doesn't matter which way we count. We're just counting the total number. That's what that 1 helps us with, right? We give the bigger unit 1, then we just need to know the total number. So we have 1, 2, 3, 4, 5. What comes next? Remember, this is a jump of 3, so it's 6, 7, 8. So this would be a 10 to the 8th. And again, what this means is that 10 to the 8th, right, or 100 million, right, is equal to 1 mega, right? 100 million centas is equal to 1 mega, which works out. And so we take a look at this, and we can, again, put this one into our calculator. But again, we're multiplying here, so it's really going to be negative 4 plus a positive 8. So we should have something about 6.78 times 10 to the fourth, but let's just make sure because we rely on our calculators. Times 10 to the negative fourth, right? Times, because it's on top, 10 to the 8th. And what do I end up with? 67,800, which is 6.78 times 10 to the fourth. Exactly what we said. So we have 6.78 times 10 to the fourth centiseconds. So when you look at it, just like this could have been 1.3 times 10 to the first, right? kilograms. Really, when we're doing these, it's kind of just changing. We're not doing anything with the numbers out in front. We're just changing the exponents of the 10 to the. Okay, so try C out. All right, try C